In this video, we're going to look at measurement, specifically about perimeter. Our learning intentions are to be able to explain what the perimeter is, to understand that you can mark two or more sides of equal length, and to find the perimeter of a shape where measurements are given. And our criteria for success will be to be able to explain what perimeter actually is, to identify sides of shapes as being equal by using various marks, and to find the perimeter of a shape when the given measurements are provided. Our key ideas today: that perimeter is the distance around the outside of a two-dimensional shape. So here we have a shape, and if we were to add up the measurements of all of the sides, we would have the perimeter. In equations, we usually represent perimeter as a capital P. And where we have sides that are of the same length, we can usually just represent this with a mark. We can see that in this image that we have to the right, where we have the little red lines on three of the sides, which indicate that each of those three sides is the same size, which means we don't necessarily have to show the actual measurement. When we have a side that is an unknown length, such as the one in the image with a question mark on the right, we can sometimes determine what that size is by looking at other sides of the shape. So in this case, we can look at the two vertical 5 centimeter lines, and we can see that they actually equal the same as the unknown side, so we can determine that measurement from there. Now that we have all our side measurements, we can simply add those up to get our final measurement, not forgetting to put in the unit of measurement, in this case centimeters. For our first question, we need to find the perimeter of the shapes provided. It's important to note here that the question does specify that these are not to scale, so again there is no point getting out a ruler to try and measure these because they are not drawn to scale. The first one's fairly straightforward. All three sides of this triangle are provided, so we simply have to add them up. So we're going to write P in capitals equals 3 plus 5 plus 8, and that of course is going to equal 16, not forgetting the unit of measurement, centimeters. In our second example, we have a 4 centimeter base on this triangle, one side listed as 7 centimeters, but the other side is unknown. But we can tell because of the little marks on those two sides that this is in fact 7 centimeters as well. It is a good practice to always label every side of your image. So even though it's got the little marks on it, I am going to label this for my own reference, just to make sure I don't get it wrong later on. So now I can simply add these up as well. So my P, or perimeter, is equal to 7 plus 4. And that of course is 18, and that is still centimeters as well. Question 3 asks us to find the perimeter of the shapes. It's also made a note that all corners are 90 degrees, so we can be sure that we have 90-degree corners, and again diagrams are not to scale. Here we have a sort of rectangular shape, but one side is unknown. I'm going to label that again for my own reference with a question mark for the moment. So I've got a 12 centimeter side of 4. I've also got a second unknown, so I might call that one A actually. So I've got an unknown side there, and I've got an unknown base at the bottom. But I can infer those measurements based on other measurements that I can see. So for example, where I put a question mark on that base, that is the same as saying the 4 centimeter part directly above it, and also the 11 centimeter part directly above it as well. So what I've got is two sections that I can take from known amounts. So it's 4 centimeters there from this part up the top, and 11 centimeters there from this part. And so those two together, of course, give me a total length here of 15 centimeters. Now, where I've got this A that is unknown, I can do a similar sort of thing. What I have is I've got a full length side over here on the left, which is 12 centimeters, and this A is the same as that 12 centimeters plus this 6 centimeters here on the far right. if I think about it, if I was to extend up that side, so it was the same length as the 12 centimeter side on the left, this dotted line part would be the same as the A line that I don't know. So if the left hand side is 12 centimeters, and I know that this right hand side is 6, that means that this A here is going to be 12 minus 6, which of course is also 6 centimeters. So I'm just going to label that as well. So now that I have all the sides labeled, I can go around and just add them up. So my perimeter P is going to be equal to 12 plus the 4 at the top, plus the 6 coming down that was A, plus the 11 going across, plus the 6 going down on the right, plus the 15 at the bottom. So if I add that up, 12 and 4 is 16, plus 6 is 22, plus 11 is 33, 6 is 39, 15 is 40, and that makes 54. So again, with my unit of measurement, it's equal to 54 centimeters. Now question 4 is a worded problem. A square has a side length of 2.5 centimeters. Find its perimeter. Now it's always a good idea to draw any shapes that you're given in a worded problem and to label everything to make sure it's really clear in your mind what you are talking about, and also helps to make sure you don't miss anything out. So I'm going to draw a square. It doesn't matter if my drawing is not perfect, because I'm going to indicate that all 4 sides are the same with a mark. Okay, now one side we've been told is 2.5 centimeters, so we could write that in. And again, we don't have to label every side because we can clearly see that they are all the same. But if it helps you, and just for clarity, you can certainly label every side. Okay, so now that I've got my 4 sides, I can work out my perimeter P is equal to 2.5 plus 2.5 plus 2.5 plus 2.5, which of course is equal to 10, and don't forget the unit. Or a more efficient way to write that would actually be perimeter equals 4 times 2.5, because we have 4 equal sides. Of course, that will also equal 10 centimeters. Question 6. Here we have a problem where we've been given an image, and the white lines on this court, that's what the image is of, are marked in chalk. The measurements are given in feet. Now, before that concerns you, don't worry about the feet measurement. We're not learning how to actually use feet and inches. We're just using this as an example. It'll be clear why in a moment. So for the purpose of this particular part of the question, we can just ignore the word feet and just concentrate on the numbers. So for A, it wants to know what is the total number of feet of chalk required to mark this out. So really what it's asking is, what is the perimeter of all of these lines? So again, not every line has been labelled, but we can infer, or we can work out what they are based on other lines. So if you think about it, we have this top line here of 20 feet going horizontally. We also have another one here and another one here. So what we have is 3 lines that are 20 feet long. So I'm going to start writing out my equation as I go. So my perimeter is going to be equal to 3 times 20 feet lines. So 20. And what I'm going to do is I'm just going to cross through them to make sure I know that I've done those ones. Now I'm going to look at the long sidelines next. So on the right here, I've been told that half section is 24 feet. So the half is 24, and if I want to know the full length of one whole side, it must be equal to 48. And I've got 2 of those. So I'm going to go 1, 2, 3, and 4. So I'm going to write, that's plus, sorry, not equals, plus, I'm going to keep it as the 24 feet, so it's plus 4 times 24. So that's those lines done. I have this 16 feet one here, and I've got one of those. I don't count this middle because I've already counted that as part of the 20 foot because it goes across these little bits on the side. So I've got this one here and I've got this one here. So I've got 2 lots of 16, so 2 times 16. And the last ones I've got is these smaller inside side pieces, which, like the big ones, I've been told what half is. Half is 12 foot. So I've got 4 of those. So 1, 2, 3, and 4. So I go plus 4 times 12. So what I now have is a formula that will give me the answer to what this chord is marked out as. So again, I should make sure I do one set of brackets at a time, one part of the equation, just so I don't get confused. So my perimeter now, I'll just work this out, probably fast forward this as I go through the math. Okay, so I ended up with 236 feet, and I have included the feet measurement back in. Even if I don't understand what a foot is in measurement, I still will write the unit of measurement in. Let's have a look at what part B then says. It now asks us to find out, or to convert our measurement from feet into meters. So it says here that there are 0.305 meters per foot. Convert your answer from A into meters. So my answer from A, I'll just write it on the side here, was 236 feet. So now I have a situation where I just need to convert this into meters. So really what I want is to do a multiplication of 236 feet by 0.305. So remembering to do multiplication of decimals, I just ignore the decimal place for a minute, remembering there are 3 though, and I do that as a normal multiplication, and then I'll add the decimal places back in. So again, I'll just do that quickly and come back with the answer. Okay, so I've got 71,980 is my answer. So 71,980. Technically, remember, that's like having a decimal point there with a 0, but I need to add in my 3 decimal places that I originally had. So I'm going to move that 1, 2, 3 times. So my final answer is equal to 71.98, and I don't need the extra zeros, meters. Being a worded question, though, I should write it as a worded answer. So the court is 71.98 meters of lines. Something like that will do. Question 7. Only some of the sides of this are drawn with lengths. Find the perimeter, and again, all corners are 90 degrees and diagrams are not to scale. So here again, we are looking to infer the measurements based on what we've been provided. So the first easy one is we've got the 10 centimeters here on the right, so this side on the left is also 10 centimeters. It's the same as the one on the right. We've been told that this first vertical line here is 4 centimeters. It's been listed over here. So each of these other sides is also 4 centimeters. So we could write those in. It might be a little tricky on this computer, but we'll try. All right, so we've got all of those listed as 4 centimeters. What we don't know is these top pieces, all right, and these bottom pieces here. There's nothing else so far that's telling us what those are. But again, if we just think about the shape for a moment, if we were to take these bottom pieces and move them up to the top, they would fill in these spaces here. And we would then have a full line that goes across that would be the same as this 18 centimeter at the bottom. So we haven't got rid of them, we've just moved them up to change the shape. So we've got another 18 up the top here. So to work out the perimeter of this one, what we have, perimeter equal to, let's take this 10 centimeters, so I'm going to cross them off for the go. So we've got this 10 centimeter here and this 10 centimeter here. So we've got 2 times 10. We've got this 18, and we've got the 18 that we made, which is made up of this piece, this piece, this piece, this piece, and this piece. So we go plus 2 times 18. I might just put brackets around these. And then what we've got is this one in the middle here, 2, 3, and 4 that we know are all 4 centimeters long. So we're going to have plus 4 times 4. So that's all the pieces of our shape are used up. So we'll just do our math here. So we have a final answer here of 72, but let's not forget the centimeters. And that is what we're looking for, 72 centimeters all around. Question 8 says find the perimeter of the shape, giving your answer in centimeters. So here we have another triangle with one side listed as 7.1 centimeters, and we've got two other sides which we know are both the same because of the marks that have been added. But the measurement we've been given is 168 millimeters, but it wants the answer in centimeters. So there's a couple of ways to do this. We could go ahead and work it out and then convert to centimeters, but the smartest and easiest thing would be to convert this 168 first of all back to centimeters, so then it's just an easy addition to do the perimeter. So let's first work out 168 millimeters into centimeters means that we're going to divide this by 10 if we think back to the last session where we were dividing and converting, between millimeters and centimeters. So we're simply going to move the decimal place. So we think about the decimal place being here. We're going to move it one space to the left. So really this is equal to 16.8 centimeters. So now that we know that, we can simply do our perimeter. So P equals the 7.1 at the bottom plus 2 times 16.8 centimeters. So we worked that out. It's 7.1 plus 2 times 16.8 is 32, 33.6. All right, and then we add those up. So we got 33 and 7 is 40, plus the 0.1 and 0.6 is 40.7. And don't forget the centimeters that we want at the end. Question 12 is asking us to do something very similar, but to write it as an algebraic rule. Now, you may not have done much algebra yet, but we have done substitutions in previous year levels. So what we have here is a triangle where one line has been represented by the letter A, another line being represented by the letter B, and also, just like before, we know that the other line that's left here, because of the little double lines, is also going to be a B. So let's write that in there to make it clear for ourselves. So the formula for our perimeter would be equal to A plus the B plus the other B, or if we want to be even better about this, we're going to write it's equal to A plus 2B, where 2B is the same as saying 2 times B. It's a simpler algebraic way of saying 2 times something. We just put the number at the front, we get rid of the multiplication symbol, and we have our letter next to it. So that is the answer that I'd like to see, A plus 2B. Of course, you could write 2B plus A. It would be the same thing because we know with addition, it doesn't matter which order they're in. Either one of those answers would be ideal. And question 13 is again asking us to write out an algebraic equation, so just like we did in question 12, but again it's a more complex shape, so we have to think about what some of those measurements might be. So a little bit like before, we're going to label these. So up the top we have an A, and we also then have a B a bit further down. And if you think about those two lines, so if we were to put B across here as well as a dotted line, that would be A plus B, and that would be the same as this bottom line. So we're going to call this A plus B. We don't know what the numbers are, so we can't physically make it into one thing, but we'll call it A plus B. And in a similar fashion, we've got this vertical line here, and we've got this vertical line here, which we don't know, but they would be the same as saying C. So if we took this one here and moved it across into a dotted line, all the way down, we would see that's the same as another C. So let's call it that, and we'll cross this one out so we don't get confused. Okay? So what we now have, and so we should just cross this out so we don't get confused as well. So what we have is we have an A across the top. We don't have this vertical line here anymore because we've included that over here as part of what we're calling another C. We've got a B going across this way. We'll call this a C going down here. We've got an A plus B at the bottom, and we've got an actual C on the side. So let's just go and work these out. So we've got perimeter equal to an A. We're going to say plus a B. We'll call that C on the right-hand side, plus another A plus B, that's our bottom measurement, and then plus the C from the left-hand side. If we look at all those things, we've got some like terms. So we can say we've got an A and another A. So that's 2A. I'm just going to cross them out here to make sure I don't forget. And then I've got plus, I've got a B and another B. So I could say 2B. And I've got a C and a C. So I could actually say plus 2C. So that would be a really good equation to represent that particular shape. So 2A plus 2B plus 2C. Now don't be worried if that one seems a bit tricky because again we haven't technically done algebra at the time of this video, but you have done some similar work in the previous year. So hopefully you can sort of look through this and be able to work out what we've been doing. So again, as always, thanks for watching. Hope you have been able to understand most of this. For the ones that you've struggled with, go back and watch them a few more times if need be, and make sure you have a good go at all the questions that you